So good morning, everyone. It's 9:05, like in the program, so I think we can start. Welcome to the 7th International Conference on Small and Medium Wind Energy. And we are in Folkecenter here. I will tell a little bit more about that later. But just so that you know a bit about the program of this couple of days. So we will begin today, like this morning will be a morning session. So we will go on up to about 2 in the afternoon Danish time. And then tomorrow we will have an afternoon session only, which will go between roughly 4 and 7:30. And that's because many of the speakers of joining tomorrow are actually from the US. So of course the time difference, it's, yeah, we'll try to be nice with them and not to make them wake up at 3 in the night. Otherwise, the point of this conference here, it's well, to join the small wind community together as a yearly appointment, and then to try to look also a little bit more in the what are new markets, what are new possibilities for small wind, both in terms of technical and in terms of business opportunities. So ideally, our program would have been divided in specific sections so that you would have first some technical and then some business and then some integration. But of course, we are online and many people have other appointments. We have time zones. So we try to pack it as good as we could. And then when we will give out the links with all the recordings, we will structure them in a little better way. I hope that's okay. And I would also, before starting, it's quite important, actually, I would like to thank Belgian Wind Power for supporting this event so that it can help us having this event for free to everyone. And I would also like to thank, ahead of everything, all the speakers that will dedicate time for this appointment. So enough talking for me, there will be more later. So our first presenter, it's from Denmark, actually, from Aarhus University in Helming, and it's Michail Beliatis. I don't know if I...
Hi, everybody. Yeah. Thanks. Thanks for the kind introduction.
Thanks for joining us. So, yeah, you will talk about blockchain and apply to wind energy. So we are eager to hear it. And the floor is yours.
Good. Thank you very much, Daniel, for the kind introduction. Let me share my screen and let me check, like, if we can share the screen, like, maybe. Let's see, like, I think something like that.
Yes, we can see it.
Okay. Can you see now?
Yes.
Good. Okay. Yeah. Hello, everybody. Thank you for the invitation. My topic is blockchain. In how does blockchain help, like, wind industry? So a few things about me, quick, like, and where I'm located. I'm in Aarhus University here in Denmark at the Herning campus. So I believe you are close to the Folkecenter, like, from what I have been told. In general, like, my background is quite wide: electrical, software, electronics, and nanotechnology, with materials there, primarily for printing organic solar cells. And then I moved to EOT somehow. And I have also experience from industry. I work as a design engineer in a few companies and some automation system. Now I'm working as an associate professor here in Aarhus University. I have 50-50 teaching and research. So my main interest is like digital manufacturing, IoT, Industry 4, robotics, and then like blockchains, additive manufacturing, recycling materials, let's say, on different topics like combining business and technology. So, and I'm leading also a research lab. It's a research and teaching lab called Digis Microfactory Lab. You will hear more later. So a bit about my research, like we are involving both quantitative and qualitative methods. We go, like, we have both profiles, technical and business. So we go typically inside for the research inside in companies. We map them, and then we deploy some technology. We see how does technology can improve this company, the operations, and to register that, and then we get some results, some detection from what's happening there. So primarily for manufacturing companies. The lab which I'm running, as I say, is like a digital microfactory lab. We are focusing digital, lean, and green factors of future manufacturing, and primarily for the focusing on the areas which, let's say, the local industry needs. So, and this is primarily metal industry, wind industry, food industry, and a little bit automotive industry. So, for example, a project which we're going to have soon, going to start, is how can we recycle fiberglass from wind turbine blades and also from automotive industry. And if anybody has a good case, you are very welcome to contact me. I'm looking for interesting cases. Good. So about the lab, we have quite a few things, focusing on digital manufacturing, as I say, in a small scale, microfactory, with a lot of robotics. We inspire from industry of car manufacturing because they have a lot of digitalization there with robotics and stuff. And we have a few different things I can put an example which we can use for teaching and for research with assembling of robots, and then we can see we have some students which we train them first in the lab, and then we can send them in the company and then do research through them. They're our ambassadors and our contact points inside the industry. That's how we do research inside the industry. And with that, yeah, we have quite a few things inside the lab. So you can see from networks to robots, SCADA, ERPs, and so on. With that, I would like to join in the research topic, the talk for today, blockchains for economy of scale in wind industry, and a demo case. So this is a project which just finished last summer. It was a lot of people which they involved, as you can see. I'm just presenting here, I was a technical manager then. So what is the case? That's a project which is run by local industry here in Denmark, about how can we use new technologies to keep transparent and traceable all manufacturing and service operations for wind turbines in small, medium, and large scale over the entire operation of 25 years, let's say, average. Yeah. So that was the main question, which it led to start mapping first. We found some local industries here, Siemens investors. So we got first to map the process, what is happening over the manufacturing process and operations, and then if we can use blockchain, a new technology, which is hot topic these days, in helping this kind of manufacturing process in the industry. Primarily, we focus on tracking fasteners and bolts, commodity components, let's say, and this is because these components are used in big scale, and also you need to trace them in order to let's say mitigate any disputes which you have if they occur. And what I'm saying that when you manufacturing wind turbine, any scale, you need to put some bolts and make sure that all the bolts they are according to specifications there. So you need to have some kind of digital verification. And this is during the manufacturing. When you go and you install the wind turbine, you can say here in the map which you have, you need every 2 years typically, you need to inspect, you need to do some service. If the where bolts and the fasteners are there, and if they need to be replaced. And again, you have a contractor, which typically you send them outside, and then they need to somehow verify that these bolts and fasteners, they are there, they are tightened, correct, they don't have problems, and if they need some to replace, again, they need to be replaced, to be tracked. And as I said, it's like the benefit, it gives you like a benefit to be able to trace all the different components in case of any big dispute. So for example, if something, there is an incident, wind turbine falls down, then what happened is like, because you need some bolt, it is like a material failure. Okay. So in the project involved quite a few people, like departments, like us from Aarhus University, here the business development technology, Fraunhofer, company about APQP wind here in Denmark, and then we have some stakeholders from industry, Vestas, Siemens Gamesa, and a few other smaller. So why blockchain for tracing these components? Like basically, it is technology which it does allow immutability. So when you write some data, you can secure them in a way that if you want to change them, you cannot change the actual data. You have to put another command, let's say, in the system, which says that I change the data. So you can trace basically every change. Yeah. In that case, also is like transparent, because everything is recorded with a timestamp there. And because you have like kind of the system, how it's made is like based on servers which they are around the cloud. Okay, so you have multiple servers, not just one computer which you store the data. All of them have to change all the traceability. So kind of create kind of traceability and transparency, like, and like trust in the owners. Because if somebody wants to change in one place, he cannot do it. It has to be changed, like triggered in all the different servers. Furthermore, the technology is using all the latest high security and encrypted protocols. Okay, so it makes sense that like it's robust against like hackers and cybersecurity, and like all the best. It can be utilized from any IT systems, like like with good manners, based on the experience which the industry acquired, the IT industry acquired over the years. It is distributed, as I say, and then it can be like peer-to-peer, meaning that you don't need to have like it can accommodate that. You don't need to have like an intermediate person which is involved in order to make this happen. Okay, so it can be like a few stakeholders, like for example, like the manufacturing, and then the first or second tier suppliers, and then you can have like a server, different servers, and then it can be the data peer-to-peer, like exchange in the system. So for the demo, which we develop, is based on a small wind turbine here in my lab, and based on like the interviews which you had, like in the needs from the industry, primarily from Siemens and the Vestas. So let's say the abstract architecture, you can see it in this slide, is like you have like the wind turbines with like the nuts and all the systems, and then you have like an EOT edge device, like typically is like a wrench, a digital wrench, which you can apply some force, and then you can see like record digital, like how much force you apply, and then you can transmit this data over a gateway into the cloud, which can be different technologies, like you can use like 5G, LTE, 6G, wireless LoRa, so all different technologies, agnostic. And then all this data through the network, they can be transmitted into, like they go into a blockchain, and then all the different partners, which let's say the blockchain system is a kind of private network, let's say, if you want in a very simplified way, which every partner, every stakeholder, it can log into the system with secure credentials and monitor the different add or monitor different data from different operations. So it can be like from the manufacturing until the operations which you have like in the field, like. And with that, like, you know, like this an abstract, a bit more detailed abstract figure of the demo. So the process, what we identified, it was like how to make it work, like you know, register all the data into a blockchain. You have to register an ID of the component, the board or the wind turbine, where you will place it into a blockchain like Ethereum or Bitcoin. It is everything is possible, together with a QR code to identify that this is like the unique system. And then basically you tag the different components, like with the data, with the actual field, like where you are located, and the operation, like so it's like tightening or replacing or something like that. Register like everything on the fly, let's say like in the blockchain. And then you like perform actions for monitoring and tracing, like later on if you need to access this data. This is like the small wind turbine which we used for the demo, like primarily inside the lab. But now we are looking for like if we can expand that into test that model which we developed into you know, a real wind turbine with collaboration with Siemens and Vestas, like let's say like if it will happen. Yeah, and here is like kind of the brief interface which we developed. Like so, for example, you have like from one side like the supplier, you can give that to a supplier, so you can register which is the supplier, what is the batch number, the material which you use for the bolts, the location, the model, and then the employee who made this batch. Okay, so you need to have like, and then you can attach also some files if you need to have some drawing or some specifications. This creates automatically a QR code which is relating to the batch, the nut, the bolt, and the supplier. And then you can utilize that in the previous, as I say, in the previous map here, like to register like the bolts with wind turbine and the blockchain system. Okay. And here kind of overview of the programming interface which we use to develop that system, to connect all the systems and have the data flow. It seems simple because it's like low code programming, but when you click inside the different bars, different boxes which you have there, we have quite a lot of substantial encryption and programming nodes inside there. So with that, yeah, we develop a prototype which can be used like for all kind of wind turbines, any kind of size, the small, medium, and the large. But also it can be used also for other systems. Like recently we had the manufacturing which is doing engines from for a marine, and they use a similar like concept. Like they have like 25 years lifetime, and then they need to trace everything. So it is widely applicable, that application. Yeah, it is IoT enabled, so it means like it can enable a real-time data exchange and you know, like minimize any errors from the operator during maintenance phase, and any anomalies and components from such broken bolts that can be identified and traced in the proactive actions. And then the blockchain technology which we propose is like well secured and robust technology, which is like utilized. A lot of people probably will know it from the cryptocurrencies. So it means like if you can use for cryptocurrencies, is tested, is secure, is like a system which you can dependable. So you can use it also for other operations, such like tracing, manufacturing, and operations inside the manufacturing setups. And with that, I would like to thank you and finish here my presentation. Open for questions if you have anything. And you're welcome to contact me if you have any question. Here is my details. Or there is also a paper. I can forward the paper if you want to read further the details for the project. Good. Thank you. Any questions? Daniel? I'll stop sharing. Maybe. I guess there is no question. So, Daniel, we have somebody. Yeah. We cannot hear you. I think still you're connected. Yeah. Daniel, can you hear me? Or anybody?
Yes, sorry. We had a really bad day with technology today.
Okay.
So I couldn't unmute for a moment.
Yeah, no worries, no worries.
So I actually, well, first of all, thanks for the presentation. I have two questions. First, it's the paper you're talking about. Is it open access? Can it be accessed by anyone?
I don't remember if it's open access, but I can check. But for sure, I can share it with you. Like I can send you the link, and then you can read. Like it is like published in a conference. So I'm not sure if it is like open access the conference or the proceedings, or you need to.
No, and of course you can.
Anyways, I can share it. Like there's no problem.
Yeah, and then I mean, you can say if we just share among the participants, or if you wanted to publish on the page. We just have the link, and then whoever has the access can read it, of course. That's,
for sure. And on top of this paper, we have like a white paper, which is open access. Like you can access it in the. I think there is hosted in the funding body, like the industry fund. Like so, there I can send you the link, and then you can read it like. The whole case, like how.
Yeah, that would be great. I mean, all kind of material that you want to share with us as extra, that's always welcome. And then the second question, it's to tease you a little bit, because the advantages of blockchain are clear, especially when we talk on the social point of view, if we talk batteries, and so where do the batteries come from, and so on. But there are a lot of critics on the energy consumption of blockchain. And when we look at small wind industry, which is not the big megawatt scale, but small kilowatt, do you think it still makes sense? And if so, in which way, let's say?
Yeah, I think it makes sense. First of all, before 2-3 days, I think happened the merge of the Ethereum. Like, so you can see like they switch from high power energy computational computers to very low energy computational computers. So it makes sense like to use it in that sense, like you have the technologies available there to use like blockchain without consuming very high power. The other thing is that, and actually I read an article yesterday which says that the global energy fall down 0.1 because they switched like into from the Ethereum they switched the servers from high energy computers to low energy process. So it is possible. And then the other thing is like we should not correlate the energy, the produced energy, with the energy which is used with servers, because there are two different things. Like one is like used locally and produced locally, and the server it could be somewhere like in outside from a nuclear plant, so the energy there is like very high. So yeah, I think it makes sense, like in short, like let's say.
Yeah, it was just to tease you, because I've heard of many people saying, when you apply blockchain to renewables, that you're actually using a lot of energy to create something that you should not need. But yeah, of course.
But as you see from the industry, the blockchain industry, there is a big move, like, and it's not just words, it, you know, it's facts, because it happened like before 3 days. Like, I think the switch of the Ethereum, like, which is the second biggest blockchain, let's say, cryptocurrency, like, protocol for blockchains, switch from high energy process to a very low energy process. Okay.
Okay. Any more questions from the audience? It's still early in the morning, so our people from US, they are still sleeping. But I guess they might come with some questions to you. You have left there.
Yeah, absolutely fine. Like, you know, you can send me an email. You have my details, so everything is welcome.
Perfect.
Good.
Thanks a lot.